third-party inspection. So if your lab can't handle a certain part because of equipment limitations or needing a third party to verify measurements, us and another coworker, Zachary, in the lab will be taking care of that for you. So feel free to contact us if there's anything there that you need. We've been seeing, especially with what's going on in the world lately, that more people are working from home. And also we've seen a lot of people getting backed up on their machines of needing to program, but also running parts. So we thought this month that we would talk about offline programming, fixturing to be able to measure more parts and more repeatable programs. And also we wanted to kind of cue you into a little bit of GD&T that we will most likely be talking about next month in the free webinar, and some system setting, some that are simple systems that you probably use every day on your MicroView. And then there are some systems that you see uncommonly but need to use. And some of the questions that we get most commonly using gaps, offset origins, and stuff like that. So we're going to jump into that. So a lot of stuff to cover today. So let's get into it. Like I said, we're going to talk about setting different styles of systems. I have a few examples that you guys probably see commonly. And then we'll talk about offsetting a system by basic distance or angle. I have a real example of offsetting by an angle that the blueprint gives you. We'll jump in a little bit about fixturing that allows you to either fixture one part or be able to fixture multiple parts and translate the programs that you write to be able to run not just one part, but multiple parts on your stage and report all those in one run. Then we'll jump into offline programming, where we'll spend most of the time today talking about and all the benefits of it, and I don't want to say limitations of it, but the being able to really use all the knowledge that you know with InSpec to be able to go from programming off of DXF, which is a 2D file, and be able to get some 3D measurements out of it. So we'll jump into that. And then I kind of want to hit a little bit at the end of work and operator instructions, things that you can put into your program to help operators that maybe not have as much experience as you programming to be able to run programs and have a repeatable, accurate program, even if you're not on the machine. So let's jump right into it about setting systems. Some of you may not have to set a system if you're just doing quick measurements, but if you're saving a program and you want a semi-automated or an automated program, you need to set a system. Systems also are used to establish datum structures. If you need any GD&T dimensions that you need to report, like true position, you're going to need to set up a system and establish a datum. Systems also promote repeatable and accurate programs. We want to be able to put a part on the stage and click play and it run. And we want it to repeat every time that we run if we have to run 100 of the parts. So those are some of the objectives of creating a system. And if you have any questions of how you set a system on your part, feel free to contact us and we'll work through it with you. Let's go over some of the common systems that we see. If you ever went through our basic training, you did a program at the very end of it using this example of using line, intersection point, and focus point to set up a system. What this does is you're finding a sharp corner on your part that you can measure two lines and do an intersection point between those two. And then that'll set your origin of X and Y, and then doing the focus point on top of the part will set your origin of Z. And then whichever line that you're able to draw longer, you'll want to set your skew to that one. It's very important to hit that focus point on top of the part, because if you write a part, or if you write a program on just your glass stage, and then you end up getting fixturing for it, putting that focus point and origin of Z on that part will allow you to move that part in different Z heights on your fixture, and the program will repeat and run with a little adjustment on there the first time you run it, but it helps make that program solid. Another common system that we see is circle line focus point. The objective of measuring the circle and setting the origin of X and Y to that circle might be that might be your datum, or it's a good feature to be able to set your origin of X and Y to that the rest of the features kind of play off of. And the line on the edge is for your skew. Again, the focus point, setting that Z origin, and that also helps the repeatability of your program, because all your different Z heights in your program and all your focus will be based off of that Z origin, so it helps it be repeatable. Another common system is circle-circle focus point. This one we're using two circles to set our using it to set our origin of X and Y to, and then we're actually skewing between the two circles. Some of you are more visual people and want to see that skew line to align between the two circles. So what you actually could do is you could measure the two diameters and then click line. And when you click those two diameters, it'll create a line between the two center points that you can skew off of. If you want less steps, especially if it's a long program, measuring that line and setting that line on there could save you time in programming. So if you're visual, go ahead and click line in the two diameters. If not, you can trust that the skew is between the two diameters there. Those are some of the common ones that we see that help programs get up and running real quick. I know not every part is a flat part and nice like, our sample slide here that most of you are familiar with from training. But take these common system practices and apply them to your parts. I'm sure there's a diameter or two edges on your part that you can align to. Some parts, if there's no diameters and no full diameters, try radius. Radius could be a little less repeatable, but with the right fine tuning, you'd be able to do it. Let's talk about some uncommon systems using a gap. We're going to be talking about this part a lot today. We're going to use this for an example of offline programming, and we're also going to talk about it for translating the part. In this system, what I did is I created a gap between the two edges, the left and the right edges over here, and I created a bisect line in the middle to get my center line. And then I went and measured this line up here that I'm able to do an intersection point between my bisect line and this edge here to set my origin of X and Y to. And then this seemed to be the most flat part area on the part, so I put my focus point there. What this allows us to do is it allows us to control the twist of the part and the, if it's going up and down in Y. And this really locks in the part in the in all the freedom that it has there. So we're going to be talking a lot about this here when we get to it, so keep this in mind. The next one I wanted to talk about was an offset angle. Sometimes on a blueprint, you'll see that it has a diameter. That's your origin of X and Y right here. And then your skew is going straight up, but it's based off of an angle that it gives you in a basic dimension. I know my little blueprint right here doesn't have the basic dimension box around it, but we're going to pretend right here. So I actually wanted to step-by-step go through how you would do this, because we've been getting a lot of emails and phone calls about offset origins on blueprints. So let's go ahead and walk right through it. I'm going to jump over to the Inspect software, which all of you should be pretty familiar with. So here we have the gap that I had on my blueprint that we need to set the origin or the skew to. Let's go ahead and find that diameter. This diameter barely fits into the camera window. So what I'm going to do is, first thing I'm going to do is I'm going to set my origin or my diameter using more inputs. And I'm going to do a couple F-scan arcs around it so I can get the real accurate shape of this diameter using F-scan tools and not risk the tools not measuring. If I was to just come over the center of this diameter and use circle F-scan circle. I probably could fit this in the camera window, but if this diameter shifts at all in my program, it's not going to repeat. So I don't want to use that. So I got my diameter that we're going to set our origin at X and Y to. Let's go find that gap. Usually when programming, I would spend a little more time trying to figure out the best lighting for this. But for time today, I'm going to go ahead and just do line, F-scan line on this edge and this edge. So we have our two lines. Now I want to do a bisect line because remember our blueprint was calling out to the center line of that. Here I got my bisect line. So now I'm going to set my origin of X, Y, and Z to that diameter, and I'm going to skew to that bisect line. Now you can see when I hit my PCS view right here, it aligns it with that gap. But per our blueprint that we had, the skew is 48 degrees offset. So what I'm going to do is I'm going to come down here. I have my line 4. I'm going to hit this button right down here. Down here we have our recall button that this is where you can make your programs fully automated. Next to it is the offset, which we'll talk about here in a second, and then working plane. When we do a webinar talking about the other options that you can get on your microview, like touch probe, rotary, and laser, we're going to jump into this icon a lot more. But for now, let's talk about offset. You're able to offset your origin X, Y, and Z in a different location if your blueprint shows you basic dimensions. If you have two diameters that it's origin and skew to, but it's giving you a basic dimension offsetting one of those diameters, this is where you would plug that in. But for this one, we're going to rotate about Z at an angle. So I'm going to type in my basic dimension right here of the 48 degrees, and I click OK. Now you notice that right down here, my origin got offset by that angle. So now when I hit the PCS view, now I have my system set up that is constructed like the blueprint is asking. Now when I go off and measure all the other dimensions on my part, it'll make more sense of if you're doing true position to any of the diameters on the part, it'll have the right X and Y locations on there. If you see a lot of parts like this, if you get a lot of prints that's asking for offset origin and you're just having a difficult time with it, email training@atiquality.com and we'd love to follow up with you, give you some support and see what you're working with and see ways that we can advance your skills in programming with those. If there are any other uncommon systems that you guys see that you're using, we'd love to hear about it. The more that we know, the better that we can train you guys. And feel free to pop it into the chat saying, you know, I use circle, gap, you know, a radius or something like that. Whatever you guys use, we'd love to see that. And you can actually send us the program so we can check out to see what you guys are doing, because we're always learning. One of the best things about going on site and training with you guys at your facility is that you guys have the hard questions and the real life questions that you guys are actually measuring parts. So we get to see more and we actually get to learn. So we're always open to that too. All right, now I want to jump into part specific and custom fixturing. Here at ATI, we have a lot of different options of fixturing. We have a bunch of custom fixturing kits that with the acrylic plate and a bunch of fixturing kits with posts and stuff that we can, you know, not specifically part specific, but if it's a quick part that we need to just measure real quick and we don't want to design a custom fixture for, we'll throw it on that. Over here, you can see we are running a program that we had our acrylic plate that we have, and we were able to put 120 parts on the stage here, and we were able to click run once, and then it went and measured all those, spit out all the data on there. So it's less time putting a part on, press and play, putting a part on, press and play. This fixture over here to the left on the top was actually a fixture that we designed and built. And this fixture was actually pretty cool because not only do we use vision, we also use touch probe. They were really thin plastic parts that we needed to secure in the fixture to be able to use the touch probe on there. Down here is another Assurance Technologies fixture that we made for these parts. We're going to be talking about this one a lot. Over here is just a little example of a multiple part fixture plate that you're able to get a fixturing kit and put a bunch of different parts on the stage. So for example, this fixture right here is able to measure over 15 different part numbers on one fixture. So using work instructions that you can put in your program, you can put a picture of where you put the part, how you fixture it, and then anybody would be able to run the program on there. And here's just some other examples of fixtures that we've created for certain parts, everything from white plastic to stamping parts to, anything that you guys make, we're able to make a fixture for. Not only is it something that we do, but it also we use all the time in the third-party inspection. If we have multiple parts, it's worth making a fixture for, just like you guys. If you guys are running 100% inspection or a lot of quantity for a lot, it's worth looking into fixturing, because when we talk about translating, you're able to, like I said, put multiple parts on the stage and run them all there. If there's any questions about fixturing or anything, feel free to contact us. We'd love to tackle any projects that you guys have and assist you with that. All right, the big thing about today, we want to talk about offline programming. I actually want to show you guys a program that I wrote that was completely off of a DXF. I offline programmed it. I wasn't on my machine, and I wrote everything off of it. I toleranced everything. I exported. I renamed everything, and I even translated it. And I put in all my work instructions. So when I was off the machine, I was able to program all this. And then when I had time, when the parts weren't being run on the machine, I was able to implement it real quick and run. So there's less downtime on the actual machine. So let's go ahead and just open up this program. I just want to show you real quick, and we're going to step-by-step go through how I wrote this program on offline programming, and you'll see all the benefits of it. But I kind of want to just show you the ability of where you can get from measuring off a DXF and tolerancing and all that to actually measuring a physical 3D part. So the first thing that happens is I have my work instructions pop up. You could have a simple picture of how the fixture is set up on the stage. You can make a PDF or Word document of, put part on here, put clamp here, as much detail as you want to get. We'll talk about if you're not sure how to insert this and have it pop up in your program. We're going to go through that today. So next thing that comes up is sample numbers. I have two parts on here, so I have sample 1 and 2. I did this little drop-down menu in the prompt because if I'm running both parts, I want the report that's going to pop up to say sample 1 and 2. And just ease of, for the operator, I didn't want them to have to type in anything, so I put in all the options here. So here I have all the different operators that we have. I'm going to select my name, click OK. It would help if I put the right part on the program, right? Not everything's perfect. Give me 1 second. I didn't even follow my own work instructions. All right, let's go ahead and do that again. Here's my work instructions. I actually followed it this time. I put in my sample and my operator. Here we go. So like I said, I wrote this whole program off of using a DXF CAD file. First time I ran it, not everything was perfect, and I had to do some adjustments. Just like that one, it's a little bit off. But here you can see that all my tolerances, everything that pops up was all ran. And now at the very end, if I want to export, I'm going to say yes. I would normally say no because it failed to measure a couple of dimensions there. But I just want to show you the report that pops up. All right, here we go. So after taking time to put in all my text prompts and everything, I have my part number reported. I have my machine reported, which I'll show you guys how to do. Some of you guys need to report what machine it was ran off of. For tracking purposes, if you guys have multiple microview machines, you can have the same program on all the machines, but you need to know for traceability which machine it was ran off of. So right here, I have a little code that actually exports the serial number of the machine. It has the lot number here. It has the sample number that I selected, the operator, and then it has all my dimensions here. You could have it show as much or as little as you want. I had this just show all features. You could have it just show export. You could have it just show tolerance features. There you go. Let's jump back here. So let's talk about how we get to this point using offline programming. Go ahead and exit out of that. All right, let's talk about benefits of offline programming. Programming off of CAD files. Programming off of CAD files allows you to program when working from home, which a lot of us are. It allows you to program when physical parts aren't available. So if you have a new part that's coming in and you have the CAD file for it, you can get ahead of the game and start programming before you actually have it, and then do all the fine tuning once you actually have the part. And you also can program when a fixture is being built. And so if you've been running off of one part and you're designing a fixture to run multiple parts, you can offline program, do all your translating to be able to set the program up. And then once the fixture is built, throw it on the stage and get running. Another benefit of it is increased productivity without machine downtime. If you have high quantity of parts that need to run through the microview and you don't have a lot of time to kick the operator or whoever's running the microview off to do the programming, you can program off of your laptop, CAD computer, your quality room computer, and get most of the programming done with a little implementation things when you actually put the part on. So when whoever's running the microview goes to lunch or takes a break, you can really quickly go implement the program and get it ready for when those parts come down the line. It's also very cost effective. Not only is it saving you time, and it's also doubling up on what the microview can do, it's a fraction of the cost of an actual machine. Instead of buying a machine to just do programming on and another one to run parts, you're able to program, like I said, off of your laptop, off of your desktop, and it's a fraction of the cost of actually having another machine. Let's talk about some of the specifics of offline programming. I'll be honest, it's ideal for 2D parts, for flat parts. It's the bread and butter of what offline programming is for. But we'll talk about how you can do 3D parts with a little fine tuning on there. The best CAD file to use is the DXF. So if you're not able to convert the CAD file to DXF, ask engineering or figure out a way to do that. And just to reiterate it, is that DXF files are 2D. So if you have a 3D CAD file and you convert it to DXF, not really knowing what you're doing, you could get a lot of lines, a lot of edges. You could even get the tolerance box in your DXF when you import it into InSpec. We've seen that before. We'll get a DXF file and we'll import it into InSpec software, and you literally see everything the blueprint has on it. And then the program's going to try and run all the text box, all the part numbers, everything like that. So Um, you can easily go in when you import it, you can highlight everything and you can delete anything you don't need. But once you get a hang of converting it to a DXF file and the way you save it before you import it into Inspect is you'll be able to delete all that and not export all that out of your CAD software. 3D parts take a little more steps when you're physically implementing it on your machine. You can see this picture here that I said we're all going to be familiar with by the end of this is these are 3D parts, different Z height measurements. They're a lot of white on white measurements that I'm going to have to be take, and that creates a lot of difficulty when running the program. So I thought this would be the best example of once you really get to know how to program off of a DXF and implement it, this would be one of the most challenging options you would have. Also, having a skeleton program, we like to call it, expedites the programming. What I mean by a skeleton program is that if your company normally has the part number, the machine number, operator, sample number, all that stuff, save a program with just those prompts in it or know how to get those real quick when you go to start programming. So it's not always second guessing what you need to put in that program. So let's actually get to work programming off of a DXF. So I just turned my lights off. We're going to pretend like this is an offline seat, even though it's an actual machine, but it works the same way. So when I'm programming off of the DXF, I'm not going to be able to set my lights and zoom the way that it's going to be perfect for it. If you have 2D parts or you know your machine and your parts pretty well, you can set lighting values and your zoom, but I find it more easier to, when you actually implement the program on the machine, to set your lights, and because you can really see what it is. But you can, if once you get pretty advanced with programming on the offline seat, you'll be able to set your lights value and stuff before you even implement it on there. Before I jump into this, I just want to say again too that the chat box is open. It looks like it's been going a little bit there. If you don't know where that's at, go to the bottom of your screen on WebEx and it comes up with a little toggle box. You can pop up the chat box there. And feel free to put any question in there, even if you feel like it's silly or not even pertaining to this stuff. We want to follow up with you. These webinars are to advance your skills of using MicroView and the Inspect software, so we want to make sure we can help you get there. All right, first thing that we want to do is that we just opened up our offline seat software, and we're going to go, and we got the DXF from engineering, or you were able to do it. So one thing that I always catch myself doing is I always want to open a DXF, but you got to come down to import a DXF. It's just kind of force a habit. You want to open up a file, you go to File, Open, but we want to go to Import. So right here, it popped up right to it, my DXF that I want to use today. If you guys have your server has a bunch of files, save maybe all the MicroView DXFs in a certain folder so you can easily find it. So I'm going to go ahead and select that and open it up. So right here, if you've ever opened up a DXF before, if you ever imported a DXF before, we've talked about this in last month's webinar in case you missed it. It's in your advanced training manual. If you don't have an advanced training manual, again, email us or comment in the box saying, hey, how can I get an advanced training manual? How can I get advanced training at your facility or at our facility in Bartlett, Illinois? We'll go over this in depth in advanced training. So feel free to, like I said, comment in the comment box. We'll follow up with more of the details on this and the tool options. But I'm going to go ahead and just import my DXF here. So right here, if you're actually on your machine and this pops up, we're going to use this one. And the next thing that's going to ask us to set lights and zoom. we're going to ignore that. So some of this is difference between importing a DXF on your actual machine and the difference of doing it in your offline seat. So right here, I need to construct a system from imported features. So if we go back to, and find my slide, what we want to do here is we want to create that gap and that bisect line, and then create that line to do an intersection point for our system here. So we're going to actually go through with doing that. So the first thing we'll do is I will do line, bisect line, and I'm going to select those two edges. We got our bisect line there. And then I'm going to do an intersection point. Remember, construction icons always stick on until you deselect them. So I'm going to do intersection point, and I'll select my bisect line and that edge. So now I have my intersection point there. I'm not able to set my Z origin off of a focus point or an area focus yet because we're offline programming and we can't actually see the physical part to do the focus on there. But you can add it in later in your program once you actually run the parts on your machine. So I'm going to set my origin of X, Y, and Z to that intersection point, and I'm going to skew to that top edge because it's my longest edge and my straightest edge on this part. So now that I set up my system, I'm able to click Next. Here's the little pop-up that I told you about that says set lights and magnification values that you'd like the tools to use. So we're going to ignore this because we have a 3D part and it's not all going to be the same. If we just set the lights and zoom, whatever it is, and we ran the program, all the different features would try to be on that same lights and zoom. Because when you're programming off the DXF, it only allows you to do that one lights and zoom. But when we actually implement it on the machine with a couple clicks of the button, we're able to set different lights and zoom real quick on it. So I'm going to ignore that. Now we have a program in Inspect. We have it imported that DXF, converted it to a bunch of tools to use to write the program. But again, I'm on an offline seat, so I don't have the physical part to measure. But we're going to go ahead and start putting in all of our tolerances. We're going to rename some features, everything that you normally would do in your program. But the nice thing is we didn't have to go and measure all this because we imported the DXF. So the first thing I'm going to do, good habit to get into, is to come down to the bottom of your program and make sure that that dashed line is at the bottom, because then you're going to start programming from there on out. So it's going to measure all this, and then anything I do dimensionally, like renaming and tolerancing, is all going to be at the end. You're going to see me right-click, insert here a little bit later, and that dashed line, if you've never, inserted here a different part of your program, that'll make more sense then. So on my blueprint, the first thing, the first bubble is this gap right here. It's dimension 1. So I just clicked gap and I selected my two icons, two of my features in my schematic window. And notice that everything's still grayed out because we didn't measure anything. So I'm going to click F2. You can also right click, rename. I'm going to call this dimension 1. I'm going to click F3 so I can tolerance it, my gap. I look at my blueprint and it says it's supposed to be 0.88 with a tolerance of 5. Notice nothing popped up in the summary because we didn't actually measure it, but we're getting all the hard work out of the way of programming. Next thing I'm going to do is I'm going to click F4 to set up my exports. I want to export my nominals and tolerances, export my labels, and I just want to export my width. Go ahead and close that. Next thing I'm going to do is that all of these radiuses, these radii, are the same. So I'm going to hold down Control and select all of them. And I'm going to click F3. I'm going to group tolerance them. So now I just applied the same tolerance to all the radii right there. And I'm going to click F4, and I want to export all those. And then I'm going to go in and I'm going to rename them. So this is dimension 2A. This is dimension 2B. However you guys rename features, if you do a dimension or pound hashtag sign 01, 02, if it's 2-1, 2-2, this is just one way that I'm doing it. Dimension 2A, 2B, dimension 2C, and dimension 2D. All right, so I have all those. I'm going to do just one more. I'm going to do another gap down here. For time's sake, I'm not going to go through the whole blueprint that we have and rename and tolerance everything, but I'll call this dimension 3. I'm going to click F3 again and tolerance this. And I'm going to export that. All right, so now I have all my dimensions that I need. I went through and I programmed all of them. And we're able to have all the program that all the reporting that we need, because the whole point of measuring these parts is to report data, right? So the next thing that I'm going to do is I am going to set my lights and zoom for the parts. So another thing, actually, I'm going to take a step back. I'm going to right click, come up to the very top. I'm going to right click, insert here. Anywhere you click in the program, if you right click, insert here, you notice that dashed line goes there. That's where you're writing in the program. In the features list, it's going to go down the order. So anything that I put here is going to go before line 44. So I'm going to come to the top, insert here. And this is where we're able to add in all of our prompts that we need. So I'm going to go and I'm going to go to feature insert, command line. What this is going to be able to do is this is going to be able to pop up that PDF that you created, open up a picture, whatever it is. So I'm going to go ahead and find my picture that I have. One thing that you notice is that it's looking for executable files. Not everything is considered an executable file, but it'll still be able to open it up. So go down to all files, and I got my fixture picture here. One thing to pay attention to is that when you're importing this and you're like kind of tying this picture or PDF to a program, it's going to look for that file path every single time. So if you just put it on your desktop and then you move it to, say, your server or a folder, it's not going to be able to find it. So wherever you save that fixture, the picture or the PDF, it needs to be in a place that it's always going to be. I'm going to go ahead and open that, and I'll just click OK. I'm just going to do a couple here. I'm going to do part number, make something up. That's my part number. And I'm going to actually click F4 because I want to export that text. And then I'm going to do a simple prompt that I want to pick a file. The reason I'm picking a file is that if you go and create a text file with a list of names or list of sample numbers, whatever it might be, you can actually select that text file, and that's how I got all of the operator names in there. Again, something we go over in advanced training. If you're not familiar with that, we'd love to help you with that. I'm going to go and find my operators text file and say that's what I want. You can have pick list only, so if you don't want them to be able to put in a different name or you select a different name, you can just do pick list only. But also if you have other operators, like we have, let's say it's just the 3 of us normally in the lab that are measuring parts, but we know that sometimes Ryan or any of our other sales guys are going to come down and measure a part. We want them to be able to put their name in there. I would do the drop-down list with a free entry. So I'll click OK. And I'll click F4 because I want to be able to export that. All right, awesome. So now I'm going to file, save my program. And I'm going to call this May Webinar Live. All right, so now I programmed at home. I programmed in the quality lab off the machine. I didn't do any lights and zoom. I didn't measure the part, but the programs ran or written, all the tolerances, all the renaming, all the prompts that I want are in there. So now we want to go and we want to actually implement it onto the machine. So let's pretend like I walk over to my machine, or you know, Monday morning, I'm the one in the office. If you guys are doing a rotation with everything going on in the world, stay safe out there. So now I got my fixture, I got my part, I actually put it on the actual machine. So now I'm going to go, I either emailed that program from my other computer or put it on the server, jump drive, whatever it might be. So now I'm going to go to File, Open, and I'm going to find my program that I just wrote. I'm going to go ahead and open it up. So now I can actually use my lights, and I'm going to go find the part on my machine. Hopefully the WebEx software and me moving the machine around isn't making you sick. Let's go ahead with that motion sickness. Let's go ahead and move this over. So now we can actually see our part. The first thing that it's going to try that we want to set is we want to set our datum structure, which is these edges right here. So let's go ahead and get those in focus. And I'm going to set some better lighting. And so up here, we're going to zoom in on the schematic window. I'm going to go ahead and I'm going to select these two edges here. We got our two lines right there. I'm going to deselect that gap. And I'm going to right click and I'm going to set my lights and zoom. So I just highlighted those two features because it's going to use the same lights and zoom. And I just right click, set lights and zoom. I know that these radii, this edge, and these edges are generally in the same Z height and the same lighting that I'll need. And we also can go in and fine tune all of this. So I'm going to go ahead and I'm going to go and hold down Control and I'm going to select all these features. So now I have all those edges that I want. I'm going to go over to my radii. I'm going to set my lights and zoom. That looks pretty decent. You guys could also spend a little more time getting the right lighting for each dimension, each feature that you want to do. I'm going to right click, set lights and zoom. I'm going to move over here. So this is out of focus, so I want to come down and get these features in focus. Get some better lighting here. So all these lines here are all in the same lights and zoom. So I'm going to be able to just right click, set lights and zoom for those. And the last features that we need to set are these here. Now earlier I was talking about that this is a little difficult because the part is white. There's not much contrast between these edges. You see a little shadow here that might not be accurate when we run the program. So after the first time we run the program, there's going to be a little bit of fine tuning that you need to do. So I'm going to go ahead and select all these, that they're all probably generally in the same lights and zoom that I want to do. So I'm going to do auto lights, and I'm going to set lights and zoom. All right, so now I'm going to do File, Save, because now we just saved all that lights and zoom that we did for the fine tuning right here, and I'm going to run the part. First thing that pops up is our work instructions. Go ahead and close out of that. Here's all of our operators. Click OK. And now, like a normal semi-automated program, because we didn't set the recall reference system to it yet, which we'll do later, once we do our translate and all that fun stuff, we need to find the features to run the part for the first time. And we'll go ahead and measure that. Measure that edge, click continue. See the thick crosshairs, it's telling me where to go. So now the first time that I click continue, and it's gonna go and measure the rest of the part, you're gonna notice that some of the features are off and some of the lights and zoom aren't perfect. But we did all the hard labor of doing all the pre-programming, so it's just a little bit of fine-tuning that we'll need to do. And again, we didn't have to go and measure any of these lines, and it automatically did it. So there's a few features that I need to go back that it didn't do the best light and zoom that I wanted, like this. So I'll come over, I'll right click in my inputs, move here, and readjust some of these. That one was good. And so you could just go through your program real quick, click through it, and find any of them that wasn't good. So right click, move here, turn my lights on. Boom, there we go. That one wasn't good. So still, the quickness of offline programming was I didn't have to go find all these features. The DXF found the features for me. And now it's just little fine tuning through the program. If there's anything that I'm moving quicker than you know how to do, pop a question in the chat box and we'll be able to follow up. So let's just say I did all my fine tuning. We're good to go. The part's programmed. We actually have that it's, we have a fixture, so we have multiple parts on the stage. We can actually go and from this system, we'll go and highlight everything. You can also click and drag and highlight your whole program. And we're gonna right click, translate. Now it's very important before you translate to make sure that all your exports and all your tolerances got out where you wanted, because as soon as you translate, all of that is gonna transfer over to the next one. So if you forgot to do something on your first part and you translate it 100 times, it's gonna not have it for 100 of the parts. And once you run 100 parts and you lose out on all that data, it's just wasted time. So I know the fixture that I built, the next part is this far away from the other part, and I'm gonna translate respect to, we're gonna do system 48, because that's what the part program is off of. And I wanna click append copy number to feature names, because if I named it dimension 1, I want the next one to be dimension 1-2, and you guys will see that here in a second. So now we have our other part. I'm gonna click save, and now I'll run this part. I'm gonna find, the one thing I forgot to do is I forgot to set a recall ref to make it fully automated. But when you do that and you translate the part, it'll run both parts, export everything for you. And for time's sake, I wanna leave the last 5 minutes here for any questions that be able to pop in that we can explain a little bit more. And also I wanna get a poll from you guys of what you would like to hear next time on the next webinar. We have some ideas, but we also wanna see how interested you guys are in that. So there's that real quick overview of offline programming. If you guys decide that it's beneficial for your company to get an offline seat, it also, when you purchase that, tied into that purchase is 4 hours of training. So we take this quick webinar that we did for you guys and expand it to all the things you need to know about offline programming and be able to get you there programming parts while your microview at your facility or in your quality lab is measuring parts and you're not taking up time that's actually pumping parts out to your customers. So next time, next month's webinar, we'd like to start talking about GD&T. I didn't do any GD&T in this program here, but sometimes it gets a little confusing with how do you true position? Why isn't my true position reading out correctly? It might be your system. You know, GD&T is like a language. The more you use it, the better you get at it. If you don't use it and you don't know, it's kind of hard to learn a little bit. So we're here to help you get a kickstart into GD&T, or we'd love to hear any of your difficult GD&T applications on your parts. And if you're having a hard time measuring it on the microview, there are options. If you don't have touch probe on your microview, there's options like touch probe. And we're looking to do a webinar on touch probe and the use of it and attaching it to your microview. So not only do you have vision, but you also have touch probe. And we'll talk about all the other things like rotary and laser and those options there. I'm going to throw it over to Dan real quick. I'm not sure if he's able to chime in with his microphone. Was there a common question that was going through? It looks like the chat really got going there for a little bit. So real quick, if everybody's in the chat room, we're going to blow the chat room up real quick. I'd love to see how many people would be interested in a webinar on GD&T. So go ahead in the chat box and just type in me. If you know how to type emojis in the chat box, if it works, put your hand up. Anything like that. We'd love to see how much of that. If you have suggestions for other webinars of things that are stumping you, go ahead and type them in there too. Yeah, see people are jumping up. So it looks like that it's going to be a popular topic. And if you're able to send us prints, you can send prints to training@atiquality.com. And we'll be able to take a look at it of some examples that we might not see all the time. And we want to help you out on it. So here's a couple contact lists of anything that you guys might need from ATI. You guys probably have your normal contact that you talk to, your local sales rep, Ryan, myself, Dan, Zachary, whoever it might be. Feel free to send us an email, anything that you guys want to hear. We want to do these webinars for you. Anything that can make your parts run faster, your programs run more accurate, anything like that. That's what our job is, to make your lives and quality easier and more productive. So it looks like a lot there. Looks like we're going to be doing GD&T next month. So I want to thank everybody for joining in today. I want to respect your time and end this at 11. We'll stick around for a little bit. If you have any other questions, feel free to pop them in. We'll be able to answer them, and or send us your email address in there, or send us an email, and we'll go ahead and do it. Also, I wanted to mention, if you mention this webinar, requesting a quote for training on-site or a webinar or inspection project, we'll give you a special discount for joining these webinars. And I want to thank you very much. So feel free to pop any more questions in there or any other topics you want to hear in future webinars, and we'll be able to do it. So thank you very much for joining.